Don't touch it.
Okay. Alright, we're going to find the limit as x approaches infinity of 3x minus 2 over the square root of 2x squared plus 1.
Oh, you're so needy. Just because it's your birthday.
Is it your birthday, Grace? My birthday.
Now,
Birthday, Grace.
this one's a little bit different because you got a square root. Alright? Now, as x gets really big, the denominator is going to get very big as well, but it is underneath a square root. Okay? Would you agree that if we didn't have the square root there, the way I showed you yesterday would have been to just do what to every term? If we didn't have a square root there.
Divided
by the highest power
in the denominator.
Divided it by the highest power in the denominator. Okay? So if it was an x squared, alright, we divide everything by x squared. Would you agree that x is equal to the square root of x squared?
Yes.
When x is positive.
Yes.
Okay? When x is positive, which it is here because x is going to be approaching a positive infinity, okay? X is equal to the square root of x squared. Therefore, okay, you could divide everything in the denominator by this, and everything in the numerator by this. Because you really don't want to divide square roots by something that's not a square root, and you don't want to divide something that's not a square root by a square root. Okay? So what I would go through and do is I would go ahead and divide everything in the top by this and the bottom by this. You're still dividing everything by the same thing because we've shown over here that they are equivalent amounts. Okay? So if I were showing my work on this, this would be the limit as x approaches infinity. I'm going to write out an extra step here so you can see it. Alright? 3x over x minus 2 over x all over the square root of 2x squared over the square root of x squared plus the square root of 1 over the square root of x squared.
First of all, the second one, couldn't we, like, for the bottom x plus the square root of 1 over the square root of x squared, couldn't we just forget about that since that's...
Yeah, but I'm showing my steps here.
Oh, right.
Okay? Remember how I said there wouldn't be, you wouldn't probably show this, alright? You'd probably do that part a little bit in your head. Okay? You probably will be able to jump to this. You get 3 minus 2 over x all over, this would be the square root of 2.
So it is 3 over the square root of 2. Yes.
Plus, and then that ends up being 1 over the square root of x squared. Okay? I should have kept this all as one, guys, because that's not... You can't really separate them when they're underneath the square root. That was my mistake.
Alright. Good try then.
Wait, would it be over just square root of x squared then?
Yeah, it would be, but I'm showing how to make sure you divide both of them by it. It would just be over a single square root of x squared. If you want to see it that way, that's fine. And this is what you would get now using what we know yesterday. Okay, you'd be left with what?
3 over the square root.
3 minus
Next to 0.
0 over the square root of 2 plus
Next to 0.
0.
So yeah,
3 over the square root.
Alright. That's fancy.
couldn't, Or, I mean, I get that this is probably a better way because it's less prone to errors, but just when looking at it, couldn't you be like, the one usually doesn't matter because it's not being multiplied each time, and then the x squared will just be changed, or the square root of x squared and then the square root of 2.
But I want you to show your work.
Oh, okay.
Don't we have to get the radical at the bottom?
To be honest, a lot of times now in calculus, you will start to just leave radicals in the bottom because some of them get pretty nasty. So we don't even mess with them.
Couldn't we have done that last year?
That doesn't take long.
The reason we have you do it is because still, it seems like on all standardized tests, they simplify the radicals, so we want to make sure you're prepared on how to do that for standardized tests. Standardized tests that you take usually just go through algebra 2.
Well, so if you know how to do it by changing it to the top, then you know how to do it by leaving it on the bottom.
I love the IO
Does that make
test.
sense?
They're my favorite.
Questions?
There was a highlighter mark.
So,
I think I might just take it for fun.
times 8, 64. Then you go root 64 is just 8, right?
Okay? Change the problem slightly.
Uh-oh.
As x approaches negative infinity. Keep in mind, this one was positive 3 over root 2.
Well, wouldn't the top one just be a -1 and the bottom one just be a +1 since the x is squared? So it would turn into negative.
So what are you dividing everything by?
A negative number.
Positive.
But x is not positive, x is negative.
Right, but you're dividing everything, like on the bottom it's going to end up being positive because even though x is a negative, since x is being squared, it turns into a positive, thus. Oh, you're saying for the first step. Never mind.
Yep. Okay?
Yeah, we're on.
Now, because as x is approaching a very large negative number, we could say that x is equal to the opposite of the square root of x squared. Because x is already a negative number. X is approaching a very large negative, so therefore x would be equivalent to the opposite of the square root of x squared.
Can you explain that again, quick? Like
This
why-
part right here?
Yeah.
Okay, let's say x is negative 1 million. Okay? So that means this is negative 1 million right here. Okay? But if I don't have this negative sign in here, if I take negative 1 million, square it, and then take the square root of that answer, what do you get?
-1 million.
No, you don't.
You get 1
You get
million.
positive 1 million.
Oh.
Because when you square that negative 1 million, you would get a very large positive. Are you with me?
Yeah.
You get a very large positive number, and then you square root that large positive number, which would get you back to just 1 million, which is not what we said x was equal to.
Right.
So because x is negative, we're going to make that the opposite of the square root of x squared.
Gotcha.
So you do x equals the opposite of whatever, and when you're trying to find a negative.
Because x is a negative number in this case, yes. So now, I'm going to divide the top by x again, alright?
Negative then.
And I'm going to divide the bottom by the negative square root of x squared.
Is the first one supposed to have an equal sign by it, or?
No, that was the original problem.
Okay. Oh, does that mean it's equal to the one above it, or what?
This is equal to this, which therefore then is equal to this.
Gotcha. So instead of writing it side by side, look, okay, gotcha.
Bingo.
Now when I take this divided by this, you would get a...
Ralph showed the camera.
I didn't hit the camera. I hit the stand.
Yeah, because it's broken.
Ralph,
That's why we try not to touch it.
Golly gee, Bryce.
Thanks a lot.
Good job, Ralph. Carmen's gonna fail her next time.
Alright, we got the, yeah, we got it.
Okay? So I divide everything by the square root of negative x squared in the bottom. That'll cancel that part out. So really then you'll have 3 minus 0 over the square root. Actually the negative's up here, really. Because you're dividing that, because you can't have a negative under the square root. So negative square root 2 plus 0, so really negative 3 over the square root of 2. You end up getting a negative.
There's the same thing, just negative.
It's negative.
Sorry, the reason I was confused before was because when I was doing it, I had it so that the x was negative, so it was negative x equals the square root of x.
But this says right here that x is negative.
Okay.
So that's-
That makes sense.
Yep. So this is actually a little bit different. This function has 2 horizontal asymptotes. Okay? And it's different. As you go way to the right, remember, the graph was approaching 3 over root 2. Okay? But as you go way to the left, the graph is approaching negative 3 over root 2. Okay? There's a good picture of it on page 202. Okay? So keep in mind a horizontal asymptote occurs
I need more paper.
at the limit as x approaches infinity, and also can occur at the limit as x approaches negative infinity, even if they're different values, which in this case they are. Okay? So you'll definitely have some with these square roots. Questions? That's what you'll do every time. You'll either divide everything by x and the square root of x squared, or x and negative square root of x squared. Okay? Alright. A couple trig ones. The limit as x approaches infinity of sine x.
Wouldn't you have it so that it's between 2 numbers? Or, because like, a sine wave goes like this, so it's not approaching a specific number. So would you say it's between the 2 peaks, or would you say it doesn't exist?
Does not exist.
Okay.
What does the sine curve do? Up to 1, down to negative 1, up to 1, down to negative 1, up to 1, down to the negative 1 forever, right? Will it ever approach one value?
No.
It keeps oscillating back and forth.
So you don't even put range, you just say it doesn't.
So explanation for that?
Does not exist because it just goes back and forth from 1 to negative 1, would be my reasoning.
Do you just say that it doesn't approach a single number, or do you want it?
I'd rather have some specific, because that would be the case for every then limit that does not exist.
Okay.
This is a
That's
different
fair.
type of does not exist.
And then would we just write the different values if it were like 2 sin x or whatever? Or
Yeah. Yep. Okay. This one, we're going to do the limit as x approaches infinity of sine x over x.
wouldn't it be 0?
It is, but why?
Because sine x is oscillating back and forth, so it has like a constant-ish number, and since it's over x, x is going to keep on getting higher and higher and higher, and because of that, it's just going to get closer and closer and closer to 0.
How could you verify that algebraically?
I'd probably try doing it the way that we did.
That's important.
Not work.
It is.
Well, sine values are always ratios, which are always drag so they're probably always gonna be. relatively
We end
small.
up using a fraction here.
So squeeze there.
Yep.
Going back to it.
Okay. First of all, you would agree that this is true. Sine of x is always between -1 and +1.
Yep.
So therefore, since x is positive, if I divide everything by x, this is also still true, right? Yep.
Yeah.
The inequalities don't change because I'm dividing by a positive number. Okay? And we know that the limit as x approaches infinity of -1 over x would equal what?
Zero.
0. And the limit as x approaches infinity of +1 over x equals what? 0. Therefore,
The limit.
by the squeeze theorem,
Ha-ha.
the limit as x approaches infinity of sine x over x must also equal 0.
So say we get another question like this on a test.
Yeah.
You can't just write squeeze theorem.
We would have to write out that the limit of x as it approaches infinity of 1 over x equals. We'd have to write all three of those things out.
Yes.
Then put by the squeeze theorem,
Yes.
and a graph of that is not enough.
The graph of that would not be enough.
Okay.
Writing the squeeze theorem.
On the graph is not enough.
And spelling squeeze wrong.
I see
No,
how
he-
the math
no,
works
he's
for
supposed
it,
to
but
be.
like,
He didn't think
I'm
he
just trying
Put
to
S,
understand
Q,
it, like,
easy, yeah.
like I
Square
can
it.
understand how the way that
It's the
I
way
thought
you-
about it ends up getting it really close to 0, but I guess I'm
Squares. Just
But
squares.
the graph is not something like
It's a
this.
quiz.
higher and it keeps on getting smaller and smaller and smaller.
But it keeps oscillating back and forth, but it gets closer and closer and closer to 0. Positive, negative, because
Right.
the sign keeps going through this periodic function. So yeah, that's how you can use the squeeze theorem to algebraically or analytically evaluate that limit. Logically, yeah, absolutely. The bottom gets huge, this keeps staying between -1 and 1. Therefore, the number between -1 and 1 divided by a very huge number is going to approach 0. But that would be the math behind it. Okay?
Would I have to write the inequality too on this hypothetical question?
Without this,
Or, yeah, that thing.
without this statement, you couldn't use the squeeze theorem.
Okay, so I have to put that statement,
Just put what is up on the board.
the
And
three
no
other
graph.
things,
No graph.
by the squeeze theorem.
No graph.
Why don't you write this down?
Basically, here's probably your
I'm
logical
not gonna look at
step,
him anyway.
okay? First of all, you're trying, this is the problem, all
That
right?
is too much work.
That's the problem that's given to you. You could say, that function falls between here and here.
Yes.
The limit of that one is 0, the limit of that one is 0, therefore by the squeeze theorem, the limit of the one in the middle has to be 0.
Alright, run to that.
Okay,
10-4.
Over and out.
all right? Okay, that's all I need to get to. You can pause the video.
Okay, quit creeping.